Assalamualaikum warahmatullahi wabarakatuh, and greetings to all panels and lecturers of UiTM Shah Alam. My name is Wan Adam Shakir and I will be presenting my final year project titled Multi-Objective Design Optimization of Square Tube with Circulating Failure using RSM Circumscribed CCD. So the content of this presentation will include the objective of the study, scope of study, methodology, result and conclusion of this study. So many recent studies have focused on the crashworthiness of thin wall structure, mainly focusing on circular tube, while fewer researchers have taken consideration on the crashworthiness of square tube. Therefore, here I have set up a model of square tube. As we can see in the figure, this is a quarter model of a square tube with an indenter at the top and support under the square tube, which will simulate a 3-point bending effect on the square tube using Abacus software. So the problem and objective of the study of multi-objective design optimization uses specific energy absorption, SEA and crash force efficiency as the multi-objective of the study to determine the crashworthiness of the square tube. Since fewer studies have focused on the square tube, a square tube energy absorber with circulating failure is considered a new type of energy absorbing system which will be tested in this experiment. The objective of the research is as follows. First is to develop FE model of square tube with circulating failure and to optimize the design of the circulating failure using RSM and to determine the most optimum value of specific energy absorption SEA and crash force efficiency CFE of the square tube with circulating failure. For the methodology, response surface methodology, which is RSM, is used to make a design of an experiment, which is a DOE, using 3 factors, which are the diameter, thickness and height. The minimum and maximum value of the diameter, thickness and height is keyed in the Minitab software as shown in the table to obtain the number of samples and which will recommend the parameters of diameter, thickness and height of the circulating failure. As we can see in the table, there are 15 samples which recommend 15 thickness, diameter and height of the circulating failure. The maximum thickness recommended is 3.68179 millimeter, and for the diameter 48.7272 millimeter, and height of 48.7272 millimeter. So after making 15 samples and submitted it in Abacus to be simulated under 3-point bending, I have obtained the SEA and CFE of each samples, which will be used to determine which is the most optimum value. After that, I have validated these factors using analysis of variance to determine the significance of each factor, thickness, diameter and height. So the p-value will determine the significance of the factor. It is said that a p-value higher than 0.05 means that the significance of the factor is less than 95%, which means any factors that has a higher value than 0.05 will be excluded in the next run. As we can see here, the diameter factor produces a p-value much higher than 0.05, which is 0.447 for the SEA, while for the CFE, the diameter also showed a value higher than 0.05, which is 0.638. Therefore, I have to make a second run while excluding the diameter factor, and here is the DOE using only thickness and height as the factor. This DOE produces only 9 samples, which will be made in abacus to be simulated again under 3-point bending to obtain the ACA and CFE for optimization process. This is the example of simulation for the first sample of the second run, and the ACA of CFE of each samples were obtained as is seen in the table here. So during the validation process using ANOVA, I have concluded that the p-value of ACA and CFE were significant for both thickness and height, as both of the value is less than 0.05. Therefore, optimization process can be done using this sample. So for the result, first the normal probability plot, which is to determine if the samples are a good fit for optimization process, shows that both ACA and CFE showed a good distribution of the dotted line, which represents each of the sample, and each dot is close to the slope, which means these samples are a good fit for optimization process. Next, for the contour plot, as we can see on the top right corner of the ACA contour plot here, this represents higher value of ACA as the value of thickness and height are higher. On the contrary, the CFE showed this darker region, which shows that higher value of CFE is detected on lower value of thickness and height. For the surface plot, we can see that it is the ACA is higher when the thickness and height of the screening filler is high, which is the same as the before. And surface plot for CFE showed the opposite result, where the CFE is higher when the height and thickness of the circulating filler is lower. So for the optimization plot produced by the Minitab showed that a thickness value of 2.1571 mm is the most optimum value, which produce the most optimum ACA and CFE of the square tube, while a height of 45.0284 is the most optimum for ACA and CFE. So this is the deformation of the optimized model using the parameters recommended by Minitab earlier. Here we can see the deformation of this square tube. So the calculated ACA value of the model is 1.86 kilojoule per kilogram, while the CFE value is 0.7977, which is 79.77%. So I have compared the result of Minitab and Abacus to determine the error percentage by implementing the parameters recommended by Minitab into Abacus and determine the ACA and CFE value produced. The result showed that the error percentage is really small, which shows that this result is usable, as the percentage is only 0.365% and 0.1% for both ACA and CFE. So as conclusion, the multi-objective experiment aims to optimize the ACA and CFE were achieved in this experiment, and the experiment has concluded that maximum value of ACA and CFE does not produce the most optimum value of crash performance, as the ACA and CFE has different results, and which is opposite to each other, as we can see earlier. higher SEA value is seen when higher value of height and thickness is used, while higher value of CFE is produced only when lower value of thickness and height is produced. So for the conclusion of the experiment is that SEA and CFE does not correspond to each other, which is why multi-objective design optimization process is required to achieve the optimal result of crashworthiness of this square tube. So that is all from me. Thank you.